Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about how we find the present value of all the different types of annuities using the formulas. Before we get into the formulas, let's just talk about the different types of annuities and their characteristics. So an annuity is equal payments at regular intervals. And then depending on when those payments are made, it's either an ordinary annuity or an annuity due. If the payments are at the end of the interval, it's an ordinary annuity. If the payments are at the beginning of the interval, it's an annuity due. And then each of those types is further divided depending on the frequency of the payments and the frequency of the compound periods. If those frequencies are equal, so for example, if it's monthly payments and monthly compounding, then it's called simple. Same thing for annuity due. On the other hand, if the number of payments per year is not equal to the number of compound periods per year, it's called a general annuity. So you can have an ordinary general annuity or a general annuity due. Now let's get into the formulas. I'm going to start by doing the first division, which is when the payment is made. If it's at the end, it's an ordinary annuity. And if it's at the beginning of the interval, it's an annuity due. And then the two types are simple and general for each of those. So let's start here. Let's find the present value of an ordinary simple annuity. The present value will equal the payment amount times, in the numerator 1 minus, and in brackets 1 plus I, where I is the interest rate per compound period. So if you're given the annual rate and it's compounded monthly, you would take the annual rate and divide by 12. And then it's raised to the exponent negative n, where n is the total number of payments. And all of that is divided by I. The formula for simple annuity due is very similar to this. It just has one more factor. The present value will equal the payment amount times 1 minus 1 plus I to the negative n over I, and then multiplied by 1 plus I. This adjusts for the extra compound period, which happens when the payment is at the beginning of the interval rather than the end. When the frequency of the payments and the compound periods are not equal, then the formulas get a little more complex. So let's take a look. For an ordinary general annuity, the present value will equal the payment amount times. In the numerator we have 1 minus, and then in brackets we have 1 plus I to the exponent cy divided by py. Cy is the number of compound periods per year, and py is the number of payments per year. And then all of that is raised to the exponent negative n, where n is the total number of payments. In the denominator, we have 1 plus I to the same exponent, cy divided by py, minus 1. For a general annuity due, it's this same formula with one more factor. Let's take a look. The present value will equal the payment amount times this same expression as what we have here, and then multiplied by 1 plus I to the cy over py. Again, this extra factor adjusts for the fact that we have an extra compound period when payments are made at the beginning of the interval. If you want to see how these formulas are used with actual examples, I have videos showing that on all 4 types of annuities. And I also have videos showing how you can use your business analyst calculator to do the calculation instead of using the formulas.